I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
So normally I would ask you how you're doing today, but we just finished a 2-hour meeting where we discussed a ton of podcast details.
Yeah, absolutely. It was overdue, though.
It was overdue. We had been running by the seat of our pants for a while.
Yeah.
But that included this stuff for our holiday merch. So that is really exciting. And we're going to have some new designs. So get ready for that merch campaign. As soon as it goes live, go check it out. I think you guys will not be disappointed.
Yeah, just keep an eye on our, social media, Instagram, stuff like that. And there's some cool merch brewing that we hope you guys will love.
I already do love it. I'm very excited. So this episode is going to be a little bit of a weird episode. Sometimes I like to mix it up.
Yes, I do know that about you.
So this was inspired by a few things.
Okay.
The first of which was Dr. Moon wrote in and she talked about the chemistry of eugenol and isoeugenol. They're very close molecules and one smells like clove and one smells like nutmeg. And when she wrote in about that, we read it on the Q&R episode. I mentioned that also we see that this happens with limonene. One is a left-handed molecule, one's a right-handed molecule, and it smells like oranges and lemons. I've talked about this on the podcast a few times before. Unrelated, I was looking on the American Chemical Society website and I found out that that's wrong.
The left hand, right hand for lemon and lime or whatever?
Specifically, what I said about limonene is not true.
Whoa.
I know. So the American Chemical Society was posting a video correction. They have a reactions page where they talk similar to this. They talk about topics that how they relate to everyday life. Their approach is really different. It's short tidbits, and they're a good resource. And I have linked to them before because the American Chemical Society is a reputable source. They are a peer-reviewed journal. I trust them to do their homework. They are something that I use regularly.
Yeah.
So I saw this video correction to a post they had made about limonene, and they said that's false. So they made that correction, and now I'm going to make a correction.
Okay. Interesting.
So this is a pretty easy mistake to make. There are left-handed and right-handed molecules that smell different. That does happen. However, in this case, that is not true.
Okay.
So I don't think the left-handed and right-handed molecule of limonene smell exactly the same. But in lemons and oranges, they are present primarily in one form, either the left or the right hand. We'll just say left hand. And that's the majority, maybe around 97%. And then about 3% is the other hand.
Okay.
And it's present in that roughly the same proportion in both lemons and oranges.
Okay. Got it.
So the proportion of the left and right-handed molecules in both of those is the same. But it's such a persistent myth because all the way back in 1971 in the journal Science, which is a really high-quality journal, they published a story about this. Some food scientists did.
Okay.
And it's, like I said, a really easy mistake to make because there is often different handed molecules have slightly different properties. They can smell different. They can interact with our body differently. We talked about that in the artificial sweetener episode. So because of all of that, it's a very understandable mistake to make. And further, smell is very subjective. It's hard to do smell science.
Right.
But ultimately, what they talked about in the reactions video on the American Chemical Society website, and we're going to link to that in our references. We always link to those videos in our references if we use them. Is really there are probably hundreds of compounds, organic molecules that make up the smell that we associate with both lemons and oranges. But limonene solely is not responsible for it. So I think this is really important because it shows something that's key to the scientific mindset. And this is why I decided to make a whole episode about this instead of just a Q&R correction.
Okay.
Is sometimes there are misconceptions that get spread around in the field of chemistry or any other science. In fact, someone I know teaches an entire class on chemistry misconceptions that have been taught wrong for so long that then the instructors learn it wrong and then they teach it wrong.
Oh, wow. Dang, that's crazy. There's a class on that.
So there's misconceptions. Yeah, it's crazy. I didn't get to attend it, but one of my current advisors, her old boss, taught that class, which I would love to be in that class. But also sometimes there's just new evidence or new information that we have to assimilate into our worldview. So that's your little mini chemistry lesson. But then I have some other examples of this and why I think this is so important from science history. So do you want to maybe take a shot at talking back to me about that, and then we'll kind of go into some other examples?
Yeah, so it sounds like, I guess there's not really, the chemistry piece of that is the handedness of molecules, and the fact that, I guess, in some of the research related to how that played into specific things, in this case with what is it again?
It's the limonene. Some people call it limonene.
Okay, yeah. So with limonene, there was some early, you could say, wrong research, maybe some theories that weren't able to be proven. Someone had a misconception about how that played out in real life in lemons and oranges, and how it made a difference in our ability to sense the handedness, whether it was smell or taste or something like that. Basically, just they had a theory and it ended up not being true, or some of the research that they did and the findings suggested something that ended up being able to be found not to be that case later on.
Right.
Just the fact that over time, naturally, we're going to be better at investigating things or revisiting things that we've, already looked at or found. And we're naturally going to maybe find that something was not right. In this case, it was wrong, and it got taught a lot and got spread pretty far without a lot of correction, or maybe even was corrected pretty soon, but it's hard to chase down information and make correction like that, especially in the pre-internet era. You've got books that have it written one way or something that are out there. Yeah, and one thing that I really liked in the video, the American Chemical Society video, the narrator said, "This myth that we found everywhere." Like, it really has spread so pervasively that experts in the field, reputable websites, check their sources, and that's what they found. But someone wrote in and said that's not right. And there was, I don't know if it was a journal article, but some scientists who specialize in smell basically tracked down the beginning of the myth. And again, the sense of smell is tricky. It can be really subjective. It's a very easy mistake to make. Right. If you have those left and right-handed molecules are really difficult to separate from each other. Just very difficult to separate from each other. And some kinds of molecules can interconvert back to the other one when it's in a solution. It's wild. And so if you had a tiny bit of contamination of one with the other, it's possible that the whole sense of smell would have been altered. Yeah. Wow. So it really was an easy mistake to make. And that's the importance of replicability in science. That's why we publish our methods and tell people what we did to ensure that they get the same results that we do. Got it. So this was a pretty long-standing, it took a while before this one really started being corrected, right? I mean, that's like 50 years or so of a lot of people thinking the same thing the wrong way. Yeah, even me. Yes, definitely. It seems like it's been about 50 years, and they may have published the correction, but maybe the correction just didn't get the traction. Yeah. So, and I think this is an example of the scientific system working because these other scientists maybe tried to repeat this, or maybe, who knows? I didn't look into their paper, but maybe they were trying to do something else with these, and then they realized this wasn't the findings they were having. So they went back to the original paper where this first came up, tried to repeat it, couldn't do it, and then they published their findings. You know, that is the scientific system working. That is why we have journals where we publish
That's why we have our methods. That's why we have the system in place that we do.
Mm.
And another example of this system working is how we came to our current model of the atom. So an early model of the atom is a very commonly known and seen model called the Bohr model.
Mm-hmm.
There were several people who were building up models of the atom, but the Bohr model of the atom is the idea, it's the one that we've seen, is that there's a nucleus in the middle, and that nucleus is surrounded by electrons that orbit.
Right.
And there was a lot of people who came before him, discovered electrons, did all kinds of stuff, you know. I don't understand how they did that back in the day. That's incredible to me that people were smart enough to figure out how to find that stuff out.
Right.
Without the technology that we have. I mean, mind blown, but that's okay. So this idea, it reminds me kind of a planet almost. You have the nucleus, and then there's electrons that in bigger and bigger and bigger circles are going to rotate around it. That's the Bohr model of the atom.
That's what always reminded me of in school too. Just like thinking that it was like a moon or multiple moons, you know, orbiting a planet.
Right. And actually, Bohr's model was right, but only for one atom. And that's the hydrogen atom.
Okay. Is that the one he was looking at to like make that model in the first place, or was he?
I think so. Okay. Although I don't have that information stored in my brain. So for a hydrogen atom, there's one electron that circles the nucleus, theoretically circles, and it really does hang out in an orbit around the nucleus.
Okay.
But beyond that, when you get more than one electron, they start behaving very differently. So there was just a lot of holes and questions about what was going on that they didn't have answers for. So then someone else came along after that with, I believe, the Schrodinger equation. And they discovered that really, rather than orbits of perfect circles, there's more of areas of electron density where an electron is likely to be. And they call those orbitals instead of orbits. So there's, okay, our first 1 and 2 electrons are probably going to be in a spherical shape somewhere around the nucleus. But as you go out, those shapes aren't perfectly circle. They start to get shaped more like dumbbells and weird, crazy things that almost look like the stuff they make balloon animals out of. You know, you get kind of crazy shapes going on. And so they basically updated the model with the new information. They had new explanation, new evidence, and then they updated the model, and it made a lot of sense. So ultimately, even though Bohr was wrong the first time, he wasn't completely wrong. He gave a foundation for more evidence to be looked into, and this corrected model has been really useful. Plus, the Bohr model is still used to teach in chemistry classes today about the model of the atom. So I think if we as scientists had decided back then, I wasn't a part of it, you know, when Bohr was figuring out his model for the atom, had said, no, this is the best and right one, and we're not going to change our minds. That could have done a great disservice to generations of scientists afterwards. But because they saw the gaps, admitted the shortcomings in their theories, and took steps to learn more and assimilate that into their model, we've come up with the model that we use today.
Right.
And I suspect that we'll even learn more about the atom and have to keep assimilating new things into our worldview as we keep going as scientists.
I mean, yeah, that makes sense. It seems like we hear all the time about a really cool new discovery that was made possible by some, you know, new technology that was maybe sort of around but was too expensive, or has just been improved a lot in, you know, over the decades. And it makes sense that that would really allow us to look at something like the atom more closely and learn more. I mean, it's already so mysterious. You know, I think it makes kind of sense that we would learn more over time, and that we wouldn't have like had it totally figured out back in whenever that was. I don't know. When Bohr was alive.
Exactly.
But
yeah. And so I think that that's something I'm really passionate about as a scientist, that a key mindset for a scientist is the humility to be able to say, my research, I thought it said one thing, I misinterpreted that. With more data, or with more information or with more evidence, I've come to the conclusion that actually this is what is true. And that humility and ability and willingness to change, I think, is really important to any scientist. And I think when science starts to fail is when researchers get so dug into their way of thinking that they can't assimilate new information. And I think this is also really important to talk about because this is relevant to what we're seeing happen today in our world with COVID. So I know this can be a really hot button topic issue, but as a scientist, I've seen some of these stances change over the past 7 months. And I have taken every one of those and thought, yeah, that makes sense because they're learning new stuff about this novel virus that's never existed before.
Yeah.
They made the best models and theories and conclusions that they could come up with the information they had based on other coronaviruses and stuff like that. And they applied it to this new COVID-19 novel coronavirus. And as they learned more about this specific virus, you saw the CDC and the World Health Organization change some of their approaches. And that is good science, in my opinion. And I think that that's really important. But I worry that some people who maybe don't know about the process of scientific discovery as much could misinterpret that to mean that they don't know what they're doing or that they're wrong. Whereas I see that as, this is good science, this is honest and trustworthy science, that they're willing to change their stance.
Got it. Yeah, it's been really interesting as a layperson, non-scientist, to be just watching and listening to new findings throughout the COVID-19 pandemic because a lot of times we just don't get visibility into that process. I know that it's happening all the time on journals and stuff where there's a journal release and maybe somebody releases another one later as a correction, or it just is a slight adjustment or whatever. I'm sure that in the science community, it's just so common. But for us as lay people, it's pretty strange to see something be publicly announced or shared, and then to have maybe 1 or 2 or 3 weeks later, something really different publicly shared that is urging the public to do something different. I think that's just so unusual for us. It's not something that we've had to experience very much before. There's been things like that really would be more like, hey, new findings suggest that something's bad for you. We hear that, but that's not quite the same as there's an urgent new thing and there's new information every week and we're telling you new things every week. And obviously there's many things about COVID-19 that are very unusual and are very out of the ordinary for us.
Right. Like maybe it's easier to swallow if it comes one year we hear this, and then another year there's new information that suggests this, but the COVID situation has been kind of in a pressure cooker.
Yeah.
And so we're seeing this, lots of people are working on this and it is sped up really fast and we're getting new information at a much faster rate than we did about, say, plastics, but it is the same process for sure.
Yeah. So that's been really interesting, and I haven't really experienced that before. I know a lot of us haven't. So it's kind of helpful to hear your perspective on this and other examples about how this has happened in chemistry for, a long time, or even really recently with, limonene.
Right. I wanted to do this as a whole episode because I think I've started to see that in my own mindset that I think, oh, are you willing to admit that you're wrong? That's the mark of a good researcher. That's kind of my mindset. And I've tried to really emphasize that. If I find out that there's something I'm wrong about, as soon as I find that out, I try to put it on the next Q&R episode or wherever I can fit it in. And I try to really emphasize, I'm not an expert in everything that ever happened. I'm an expert in organic chemistry. And even in organic chemistry, I can get things wrong. If I was taught wrong, or just because I'm a human, I made a mistake, I'm remembering it wrong. There are mistakes, but we do have checks and balances in our system of scientific research and discovery to try to catch those as much as possible.
Right.
And so I just wanted to take this opportunity to address a wrong thing that I have said on multiple occasions in this series of podcast episodes. But also I wanted to use it as a moment to communicate that I think admitting that you're wrong and taking new evidence to give the best information that you have at the time is the best thing we can do as science researchers and communicators. And part of what inspired that was I had a visit from a friend, and her sister was in town. And her sister's also a chemistry major.
Mm-hmm.
She has some kiddos in school, and one of their teachers has this philosophy as they're all trying to go to Zoom school together, that we're all learning and we're all learners, and learners can make mistakes, and that's okay. But as soon as we find out that we made a mistake, we're going to work to fix it. And I think as she was talking about that, I thought, yeah, that's so important to science. And we haven't addressed that explicitly in the show. And I just wanted to take the chance to do that because I think it's important. I think it's relevant to what's going on today. And I think it's always a great chance for me to be able to say I'm wrong.
Yeah.
So.
Yeah. And I think it gives me a lot of confidence to think about this stuff and kind of get a little bit of perspective of, inside perspective of what scientists and chemists and stuff are trying to pursue. I think the idea of, they're all trying to pursue the best possible science that can be arrived at the time. And so if I ever hear somebody correct themselves, really that should be maybe good news to me, because it means that they're pursuing a goal of the best possible science. And in the, if they're sharing it with the public, it's also to the public's benefit, rather than their own, maybe reputation or career or something, where they'd rather just have like a perfect track record
score.
of like never having been wrong. It shows that they're like, actually their bigger goal is the collective, progress of science rather than their own report card,
right?
Which is a good thing.
Definitely.
That's kind of cool to think through a little bit.
Yes, I absolutely admire scientists who are willing to, based on evidence, not just wishy-washy change around, but based on evidence, see that they were incorrect about something and change it. And so I was really excited when I found that ACS video. I thought, that's crazy. And I really trust them to have done their research. And I just thought that was a fun, cool example of science at work, science working well. So good job, American Chemical Society. Way to go. They have awesome resources. I use them a lot. And if you have kiddos at home and you want some experiments to do at home, they have a lot of great experiments, more than we could ever hope to cover on our Chemistry at Home episode. So definitely check those out if you want to learn more. It's an awesome website and resource. All right, well, that's it. That's all I have for you this week. Just a little bit about how I was wrong and how a bunch of chemists are probably wrong about this, and that's okay and even good sometimes to be wrong.
Nice. I like it. That was a helpful reminder and pretty relevant, but definitely cool to have an inside look into the scientific mindset.
Well, on the theme of being wrong about things, I'm here to admit that I was wrong about the show Survivor. I'm here to admit it.
Oh, no.
I know. You're not going to approve of this, and that's okay. We can disagree because this is an opinion, not a fact. So
yeah, that's true.
For a long time, I was
about art.
For a long time, I was really mad about Survivor because I hated to see people hurt each other's feelings and lie and betray to each other, because I really hate lying. I'm really mad about it. But my roommate started watching it, and it just sucks you in. I mean, you're dying to know what happens next, and the challenges are interesting. And it's fun to sit around and speculate about how you do. I would do very poorly. I don't think I'd come off well in first impressions. I would get voted off quickly for people thinking that I think I'm better than them. I already know how I come across. It's fine. But it's really fun. It's been fun to watch with my roommates. I've really enjoyed it. And the first time they got on a Survivor kick, I was mad about it and complained the whole time. And this time I am interested, and I am now maybe considering myself a fan of Survivor, but not of the lying and hurting each other part. I don't like that. That still makes me really sad.
Yeah.
And I like the people who just say what they're going to do and do it and still somehow win all the way through and don't lie and cheat and steal and backstab.
Yeah.
So that's my correction for my opinions. And I really wanted to give a shout out to your wife, Emily, who loves Survivor and laid the groundwork for me to make this transition. So thanks.
Well, the other half of you will be glad to know that I am still right about how I feel about Survivor, which is that it is garbage. So,
well,
so any
I'm
of you
just
who are worried
20 years. I was going to say I'm just 20 years late to the Survivor party, so I hope you guys will welcome me with open arms.
And the rest of you who are like, "Oh no, is everything changing? Are these people like crossing over?" If you're one of the non-Survivor people, then don't worry. I'm not going to give in. I'm staying strong.
I just want to say one thing is if any of you listening are planning on going on Survivor, just learn how to make fire before you go on. I don't know why people are still showing up on that show and they don't know how to make fire. You know that you're going to need to know how to make fire with or without a flint. Just figure it out before you go on. That's the one skill you really should have. Okay. Just wanted to share that. Okay. So that's my thing for this week that I've been enjoying hanging out and watching that show with my roommate. So what about you, Jim? What do you have for this week?
Nice. Very nice. Okay, let's see. I kind of want to like, and there's something I was wrong about too, to see if I could go on that theme. So I'm going to share something that's not super recent, but along the theme of what you were talking about, something that you've discovered you're wrong about, you've changed your mind about.
Yes, that's a good theme for this week's episode.
So one thing, so Melissa and I actually have had many discussions about this topic a little bit, specifically about reality TV. So I do not like reality TV at all. One of the big reasons for that is that I studied documentary films, like is kind of one of my main emphases when I was in school. And to me, it's, how do I say this nicely? It is certainly documentaries gave birth to reality TV in a way.
Oh, yes, definitely. I could see that.
Nonfiction film, which is the broadest category that documentaries are inside of, nonfiction video content. And I think it's a mutation in a way that has given rise to the ability of nonfiction to actually be pretty oftentimes deceptive and unrealistic, which is so funny because it's called reality TV. And when I was in school, I learned about all the, beginning motivations for documentary film. They're so good. It's like, it's very journalistic, let's tell real stories. Let's show things that people aren't able to see. Not everybody can be over here in this part of the world and see this thing. So let's tell them, let's show them. I think those really, really good motivations just started out in the documentary world. So I don't like reality TV at all. And I know I'm very much in a camp that is not the biggest camp.
Right.
With that. However, the change that I have made, not recently, but a few years ago or whatever, is that I really like the show Queer Eye on Netflix.
Yes, because it's so nice.
It's so nice. And there is a lot of setup involved. So it's not completely honest in the sense that they're very straightforward though about the fact that they have like selected somebody, they've set certain things up on purpose, they shortened the time frame, they didn't accomplish everything in one day. It's like
right.
Some of that's pretty obvious. But the reason that I changed my mind about it is because the clear goal of what they're trying to do is, I think, very good and positive.
Okay, that's a good reason. Yeah.
And it's non-competitive. I am not interested in competition, especially ones that I think are pretty frivolous and greed driven. In this case, if anything, the competition is about like helping other people.
Yeah.
And there's not a competition at really at all. It's really just
collaborative. Yeah.
Collaborative. And you get a lot of story, which is a huge part of documentary, seeing into people's lives and hearing about challenges they've had. And they pick really interesting people who really could use some help and some loving and some, a boost of positivity. Yeah. And so I really like it. I feel like it just is a net positive for that show to exist. I don't have that same level of confidence about other shows in that genre.
Right. Yeah. Well, let me just stir this in there for you, just to consider. The Great British Baking Show.
I knew you were going to say Great British Baking Show.
Is very similar, but they are competing for just literally like a plate, nothing else. And they are really nice to each other and they lift each other up. And sometimes they hurt themselves and stop working on their stuff to help other people, So that one I think has a really good, it does have competition, but that one is another one that I leave that show feeling like there's good in the world.
Yeah. I think that one's probably not one that I have any reason to launch any arguments against. It just doesn't draw me into it. I think just a big part of it not being into baking, really. And I think people might at least get hooked a little bit by the competition and then stay for the positivity.
Maybe so, yeah.
And so the idea of like just saying it's really positive, it's not that cutthroat, okay? It's a baking show. I'm already like not interested. Not that I think it's bad. It's just like, I don't think I'm going to get as much out of it as somebody else, especially Melissa, who does a lot of baking and challenges herself to make new cakes and stuff. So
yeah, I think that was the first reality show that I ever really liked, because all those other ones are like crazy baking. You got to make cupcakes out of seaweed or whatever. But that doesn't seem realistic or fun, and they're mean to each other. I don't like watching people be mean to each other.
Yeah.
It's not fun. So this one where it's got happy classical music and there's scenes of baby sheep and beautiful landscapes, and if somebody is upset, everybody's sad. Whenever anyone goes home, they all cry. They all hug the person who did well. It just feels like a show that showcases the beauty of human relationships. I really enjoy it. So
yeah, that's not the vibe typically of like an American reality show, especially a competition show. It's like, very cutthroat is much more a common approach to American competition. So
yes,
you go British show.
Well, thanks, Jam, for enlightening us about your expertise. We get to hear about your expertise for a change, which is always fun. And thanks to all of you listeners for coming and listening to us make a correction, and for listening to us talk about the scientific method and how learning about mistakes and correcting them is scientific progress. I really am thankful that we had the opportunity to share about that.
And thank you for teaching us. That's really relevant and cool to hear and get the inside scoop on that process and some examples of how that happens. Melissa and I have a lot of ideas for topics of chemistry in everyday life, but we want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. If you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and J.M. Robinson. References for this episode can be found in our show notes or on our website. J.M. Robinson is our producer, and we'd like to give a special thanks to M. Quapple and S. Flint, who reviewed this episode.